Welcome, everybody. It's good to have you here again, once again. How many new people?
Welcome.
That's good. And then how many people have never seen Marco before? In real life, I mean. Now you've seen him online.
I'm an avatar, so yeah.
Yeah. Welcome back. This is the Power BI Melbourne meetup. We've got the big crowd because we've got the superstar here today. So we're so happy to have him. He's been a regular guest of ours. About once a year, Marco makes an appearance, which is fantastic. So thanks to Marco for coming along. Before we get started, a couple of housekeeping things. The toilets, hopefully you got the message on where they are, but they're around the donut, around here if you need them. And we need to say thanks to our sponsors. So the first sponsor is Serious People. There's Bryson. I've been talking to a couple of people about Bryson. He is real. There he is. So if you're looking for people in the BI data space, or you're looking for a job in the BI data space, and Bryson's a very good person to know because he does the recruitment side. So thanks to Serious People. They bought us a whole bunch of pizzas, so you're well fed today. So that's awesome. Our other sponsor is the wonderful Cognizant. We're here in the Cognizant offices. You probably know Cognizant because they're a massive company. So this is the Australian arm of that organisation. Obviously, pretty much anything in the enterprise space. If you've got anything in data in the enterprise space, then shout out to Cognizant for their support of the meetup. So thanks to our sponsors, and we really appreciate that. So much happening in the Fabric and Power BI world. Obviously, we've just had a bunch of new things coming out in the recently. I think AI Skills got released in general public today, which everybody knows I'm excited about because I really want to try that out. But yeah, there's lots to talk about, but I don't want to waste any time talking about new stuff in Power BI because we've got a special guest today. So without any further ado, I'd like to introduce somebody who probably taught me everything I know about DAX because I did all of his courses back in the day, and probably still the best courses and information around how to do DAX, how to do data modeling. SQLBI.com has been one of those basically an industry in the Power BI space.
Thank you very much.
So we're so grateful to you, Marco, and thanks to everybody for coming along to see you. So here he is, the man, Marco Russo.
Thank you very much. Thank you very much. So today I am happy to present some tool and technique, and also some external tool, also commercial, but not also the commercial, also the free ones, to optimize DAX. So the idea is that I know this is, you all write good DAX code, so you should not have, but someone else outside of this room could write DAX that is not optimal. And so what are the tools that you can use to investigate those problems? Because sometimes you have to fix code that you wrote, but sometimes you have to fix code that you didn't write. And so at that point, we could use tools that make us more productive. So there are a number of techniques. Just to mention, we published a few months ago training that is about optimizing DAX, and it is like 40 hours of recorded video. We have a book about 800 pages, and now I have, I don't know, maybe 1 hour. I don't know how much time we have. So yeah, okay, but certain time you want to go to sleep, and so the thing is that the goal for this evening is to give you pointers, to give you directions about what to do depending on the problem that you have. So we will introduce the problem of the optimization. What does it mean? What does it mean to optimize the memory, the CPU, the speed? And then we will look at a few tools that can help you to gather information, and tools and techniques that you can use. We will not actually optimize the DAX code. I'm more focused on looking at the tools that we have available and the techniques we had to use. And then if you are interested, you will understand which area you have to go deeper. Thanks for the presentation. I don't have to introduce myself. I work at SQL BI, where we produce content about data modeling and DAX for Power BI analysis services, mainly Power BI these days, of course. And you will find everything on SQLBI.com, and also another website that I will show you over the presentation. So, performance optimization. DAX is important because when you create a report in Power BI, you actually have visualization. So the ultimate goal is to show some data in some sort of visual. But in order to populate the visual with data, the engine, we don't discuss about the architecture, but the engine at the end of the day creates at least one DAX query for every visual. So you can imagine that if you have 30 visuals, there will be 30 queries, but maybe more. And every query, every visual could have one or more measures. And the measure is the, let's say, the minimal unit where you write DAX code in your model. And so the first issue we face when we have a slow report is to isolate the problem. Because if a report is slow, if you're particularly unlucky, you have multiple issues. But usually there is one issue that is the biggest bottleneck. We solve that first, and then we try to solve the other. So, but in terms of priority, we want to provide most of the time on the more critical issue. We don't want to spend the first 2 hours on something that doesn't matter. So that's the idea. So what we have to do, we have to reproduce the problem, isolate the slower visual, isolate the slower query, and optimize the DAX measure, and then repeat until the performance is good enough. You could continue, for an infinite amount of time, but you have to say, okay, for me is enough 1 second, 2 seconds, 3 seconds. I don't know. You set the bar, and then once you reach that bar, let's stop it, because otherwise you can continue to optimize, but at a certain point, it doesn't make any sense. Now, what should we optimize? So, as you see from this slide, the more important thing you should optimize is the data model. Okay, the data model is responsible for processing time, how much time you need to refresh the model. That's not about DAX. I mean, DAX could influence the refresh time if you have calculated columns and calculated tables, but most of the time is needed to, 1, retrieve the data, 2, compress the data, 3, store the data. And so the lower the amount of data you have, the faster the processing. It's easy. You load a lot of columns you don't need, you waste your time, you waste your memory, because everything you import, it consumes memory. I use direct query, I don't have a problem. Direct query is for the rich. It's simple. Let me put this straight. The best and more optimized model in import mode, and the best and more optimized in direct query model, the direct query mode will be 10 to 100 times slower than import mode, everything optimized. And you have to accept that as a fact. 1. And we talk about the performance for one user. Do we want to talk about the scalability? Good. You are moving all the queries without any cache to your relational database. It's going to cost more. Now, if I say direct queries for the rich, is a simple way to simplify the message. But challenge me if this is not true. Most of the times, the model could be moved to import mode, at least for the data that you want to compute with good performances. When you say, oh, we can use aggregation. Come on, aggregation are an import mode. If you use aggregation, at the end of the day, you're using import mode. So we are just joking with the words, right? So that's the thing. So we focus on the optimization for DAX for import mode. Now, I would say that 50–60% of the techniques that we can use for import mode are also good for direct query. But remember the orders of magnitude of difference. In DAX, I worry about the milliseconds. In direct query, I talk about seconds. Okay, that's the order of magnitude. And just to make it clear. So the memory is important because we don't have an infinite amount of memory. Depending on the capacity that you have, you might have restrictions in the memory available, and so we want to also optimize the model. So we don't talk this evening about how to optimize the model, but that's where you should spend most of the time initially, because this is part of the design of the model. And yes, the data model is also responsible, in part, for the query response time, because a model that is not designed, not optimized well, a model that has bad relationships design will have bad performances that you are not able to fix with DAX. So assuming that you optimize everything in the data model, then DAX is responsible only for the query. Your slow DAX measure will affect only the speed of a DAX query. So what happens when you query mode? As you see, this date is a little bit outdated, but in reality, the architecture is the same. It didn't change. We can just do one thing here instead of writing here. Let me fix this. So instead of writing analysis services tabular, you can write here Power BI or Azure Analysis Services, but nothing else is changed, right? So we have the visuals that you have in the report that sends a query. If you use Excel, the query is not a DAX query, is an MDX query. Regardless of the query language, internally the engine will execute your measure. The measure is responsible for the performances, and the measure is written in DAX. When you create a tabular model, the measure is DAX. Now, the DAX calculation engine is also called the formula engine, is responsible to understand what you want to do, and then the formula engine dispatches request to the Vertipack in-memory engine if you use import mode, or your relational database if you use direct query. And at the end, these two storage engines, in reality, they collect the data from your data source. We don't have Direct Lake here, but actually what you have in Direct Lake is basically the same behavior you have in Vertipack. The approach to optimize Direct Lake is just 1 millimeter different than optimizing Vertipack. It's the same thing. There is some difference about the latency for logging some data in memory, but we can ignore these differences. The techniques and the tools and everything we use to optimize a measure in DAX for Direct Lake is the same for Vertipack. So from my point of view, Vertipack, Direct Lake, import mode, that is the part we consider. Direct query is another option. I don't enter into direct query here, but the tools are the same. A few techniques are different. So if you really want to use direct query, then you have to consider the optimization on two sides. You optimize DAX on one side, you optimize the relational engine on the other side. The database administrator doesn't allow me to create indexes. Don't use direct query. No, because otherwise you're in trouble. It's already slow, and then you cannot even optimize it. So it's a problem. So we talk about Vertipack. Vertipack, like Direct Lake, is the storage engine for imported data or for Direct Lake. How does it work? The principles are the same. Direct Lake is slightly different, but it doesn't matter for the discussion we have now. When you import data, the data is imported in memory and compressed in memory. How? Using a column-based storage layout, which means that even though you imagine the table, I imagine the table, I think also you imagine the table as a list of rows, and in every row you have a few numbers and strings, and the data is organized row by row. Imagine a CSV file, imagine Excel. When you look at Excel, the data is row, row, row. When you store this data in a relational database like SQL, like Oracle, like MySQL, this data is pretty much stored the same way, row by row. But when we import the data is stored column by column. Nowadays, there are also options to store the data column by column also in relational databases. Like SQL Server has the column store indexes, like DB. There are many other databases. And the organization that we have in a column storage format is that we have, imagine you have one file or one array in memory with just one column, ID. Then you have another file name, another file address, file or array is the same thing. Now, if you think about that, the advantage of this approach is that in case you need to aggregate this, come on, in case you want to do, let's do this. In case you want to aggregate the balance due for a number of for all the customers in a city, you only need the two columns, city and balance due, which means that the amount of RAM, the amount of data that the engine has to scan is smaller, considering compared to the entire table. So that is the idea of the column storage layout, which is the basis for the Vertipack engine. And also Parquet, which is the format for Direct Lake, is pretty much the same. Now, what happens, how this data is also, so the data is not only stored by column, it's also compressed column by column. What does it mean? First of all, if there are rows that have the same value in contiguous rows, instead of storing the data, sorry, the contiguous row is the second one. So if you look at the data, let's say that we have strings, but we could also have numbers. If my column contains only 4 unique values, like the quarter has only 4 unique values, well, instead of storing the same string multiple times, why not storing just an index over a dictionary of the values? That is called hash encoding. So instead of storing the data as is, the column stores like a pointer to a list of values, which allow the engine to store the list of unique values in an index, and the column has only a smaller integer number that usually is stored in the minimum number of bits that are needed. Now, if you have only 4 unique values, it requires 2 bits. In 1 byte, it is 4 rows. And this means that the minimal compression is we save 75% of the space, probably more, because this string was probably Unicode with 2 characters, so 4 bytes, a lot. The second optimization that is applied over a column is called run length encoding. As you see, it happens that several rows have the same content, and so why, instead of storing this data in a scattered way, if we had the same value across contiguous rows, we can just say, well, the value 0 is repeated 4 times. Then there are 10 rows with 1, 4 rows with 2, 15 rows with 3, then 30 rows with 2 again, and so on. So basically, if we organize, not we, if the engine finds a sort order of the data in order to reduce the number of changes across the value in a column, the compression will be better. It's not an easy problem to solve, because if you think for a moment, combining these 2 techniques, we obtain the optimization of the VertiPack engine. Now, when you use import mode, the advantage is that it's not your business to find the optimal sort order. The optimal sort order is something that VertiPack will find for you. That's the reason why compressing data takes time, because the engine has to load data in memory, find a good sort order, and then use that sort order for the compression. If you use Direct Lake, you are responsible for the sort order, unless you delegate this to Fabric. Depending on how you load the data into the Parquet file, into the data table format, that could be good or bad. You hardly have a better compression than VertiPack. Remember my words, you hardly have a better compression than VertiPack. So when you say, oh, Direct Lake is, no. Direct Lake is not faster. Direct Lake could be good enough, okay? It could be a good trade-off, but if you look at the performances, at the moment, I didn't see something faster than VertiPack, okay? Because the algorithm that Microsoft developed is very advanced, and it has been written many years ago and still is unsurpassed in terms of efficiency of the compression. Okay, I have my data. I want to know something about my model. Question? No, I'm saying that today, no. I said that today, as of today, it is what it is. It is technically possible to find a better optimization. What does it mean, real-time data? What is your latency? You're okay. Who is writing on Direct Lake? Who is writing on Direct Lake? Who? Row by row? I'm trying to figure out what is the technique that keeps the data in Direct Lake updated. Because if you have a batch processing that every hour, every day moves the data to Direct Lake, you don't have a real-time system. Okay, so if you have a streaming input, you are moving data in an area that is not well compressed, which means that you have to consolidate your data once in a while, which means that you could consider also other alternatives, because I have a real-time data. I'm saying that this is good. This is a good approach. I'm just saying that it's not a solution to everything, because you still have to do something, right? It's not, it just works. It is not that. And the challenges that you face to keep a consistent, consolidated view of data is the same that you have with other solutions. And I'm not saying that other solutions are better. I'm just saying, okay, there is nothing new here. We have another tool, we have another technique, we have another set of tools. But in 2000, let me think, in 2000, so Power BI has been released in 2015, and I think around 2017 or 2018, we had real-time models in Power BI with a latency of, let's say, 10 seconds with a transaction. Sorry? No, that's one technique, but you have also the push data sets. Nobody talk about that, but they are there. You can use them. Depending on the volume of data, that's an option. And if you have a larger, I mean, we have many options. We have direct query, we have this, we have that. Every option has pros and cons. You also have the hybrid tables nowadays. So I'm saying you still have to, if we talk about performances, everything has a price. The fact that you have to consolidate, sooner or later, you have to pay the price for that. So don't think that, oh, we have this magic hand and now everything. No, it doesn't work this way. The one thing is a demo, but I'm not here to run a commercial. So I'm not Microsoft. So I do a reality check. I mean, direct link is wonderful. It's a nice technology. It's just not the solution for everything. That's what I'm saying. And I'm very agnostic. And when I look at that from my point of view, I always want to be able to switch to. So if I had direct link, it's easy. If I change my mind, I just import the data and it just works. And in my experience, the real time is not something that many companies have as a problem. And who has the problem of the real time, who has the real problem of the real time, already solved it. They are not waiting for some. And believe me, I have seen complex implementation of real time. It's crazily expensive. Nobody wants to pay so much money if they don't have a real need for that. If you need 15 minutes or 30 minutes of latency, oh, come on, we have a lot of options. Okay, so back to our, so we said, okay, we have several techniques of compression, and we want to understand what the model is doing. Okay, so now we have several tools. I show you a couple of tools that we can use to extract the information from the model. We start with a tool that is called Bravo. So let me show you the website. Here we go, bravo.bi. This is an open source free tool that has a number of features, very nice. And there will be some news about Bravo later this year. But at the moment, we have this analyze model, format DAX, manage dates that create the date table, time intelligence calculation, and export data. The goal of Bravo is to be a simple tool. So this is not the tool that does everything. For that, we have a DAX Studio is wonderful, and just use DAX Studio. But if you imagine the situation where someone else created a Power BI model, they cannot send you the model, the PBX file, but you just want to extract some statistics about the model. So let's say that we have this situation where we have a model here. This model has a slow report, and we want to know something more about this model. As you see, we have here, sorry, I have to open my Zoom it. Okay, we have here a number of external tools. The tool that I'm showing you now is Bravo. Then we will see DAX Studio. So if I open Bravo, what happens is that with just one click, without any skill, any experience from the user point of view, we have a quick overview of the of where the memory is allocated for, come on, really? No. Don't ask me anything else, okay? Okay, good. So we have this view where we have a very quick overview of the more expensive columns, the sides, the cardinality. We can ask for more information. We can go in more detail. But what is interesting, so I just show you, even though it's a different font, you see that there are different columns, different size, different cardinality. Is this useful for the end user? Maybe not much, but this button for me is very, very important. Let me explain you why. The complexity of running Bravo is basically to click one button. So everybody should be able to do that. And the second complexity is to ask people to identify this button and click it. So this is 2 clicks, okay? We're 2 clicks away to export a file, a VPAX file, which contains information about our model. So let's store C demo currency, Contoso currency 1.vpax file. What is this VPAX file? The VPAX file is a format. It's actually a zip file. You can actually open it. It is a set of JSON and XML files. You can inspect them, making sure there is no real data of the model included in those files. And the file that I obtained this way, show you, the file obtained this way, if I can find it. Oh, here we go. Is this one. Okay, this file has only 44 kilobytes. As I said, let me create a copy of this. If I created this as a zip file and I open it, let's extract this. This is the content of this file. These are text file, JSON file, the bin file. And if you look at this content, it is only the description of the model in terms of tables, columns, measures, statistics, not data, just how many unique values you have in each column, how much memory it takes to store that column in memory, and so on. So by sending this 44 kilobytes by email to someone else, what can I do? Well, I can open the same file with another instance of Bravo, but if I am a more advanced user, I could use a more advanced tool like DAX Studio to open the same file. So if I go in advanced, import metrics, and I go to C demo, and here I go to currency Contoso VPAX file. So you see that I'm opening the file that I received by email. So imagine this DAX Studio doesn't have access to the model. When I open this file, I have all this information about the model. For every table, I see the size, I see the number of rows, I see for each column this information, and I can explore that. There are a number of information. You have a referential integrity violation, you have relationship partitions. If you have a very large model, you have a lot of information about where the data is stored. So that is a gold mine, right? Of information that we can use to understand what happens. But something that we don't show in DAX Studio is actually another information that I want to show, which is, let's see if I have the file demo somewhere. Come on, this bar is, can I do that? I'm thinking, okay, let's go in another directory. So C, SQL BI tools, VertiPack analyzer, okay? Because the goal is showing you the tools and how you can use them. So if I open, if you download this tool, let me show you where you can find it. So if you look for VertiPack Analyzer originally is this tool, which is an Excel file. It's an Excel file that you can download. And once you download this Excel file, you have Excel, the best product ever. Come on, obvious. So here we have in the first page a few instructions, but basically it's easy. So we have this additional ribbon. There is a macro in this file. Okay, so this ribbon has an open VPAX file. So we click on open VPAX file. We go in demo and we open the VPAX file that I received by email. Remember, we don't have access to the model. Oh, sorry. okay? And it's not very fast, I know, but in a few seconds, it will populate a power pivot model with a lot of information about the data that we found, and we will be able to navigate in a number of worksheets in Excel where we will have also access to other information about the model. I want to show them because you might decide that it's not good to export that information, but in reality, that is part of the description of the model. The DAX code that you have in a model is part of the model definition. And from my point of view, when a company says, oh, we don't want to show the DAX code of the measures to the users, I always say, why? What is the hidden secret there? There shouldn't be anything sensitive there. Anyway, so we have the same information you have seen in DAX Studio with the ability to customize your pivot table in many, many ways. But the important information that I didn't show you, because DAX Studio doesn't have a way to show this information, is this one. The file includes everything you have in DAX in the model. If I look at the table here, you see that for each table, so we can group the DAX code by table. We can group the DAX code by type, because we have DAX in this model for measures and tables, calculated tables, and measure. We could have calculated columns, row level security, and other things. So everything that could have DAX code is here. And so this allows us to have the DAX code of the model, all the tables, all the relationships, the statistics about the tables and the columns and the relationships, which means that as a consultant, I don't even start a conference call for optimizing a remote model without receiving this file in advance, because it would be a waste of time. What's the point of me asking, oh, open this file? No, oh, go there, go there. Come on, after 30 minutes, I still don't understand what we're doing. If I receive this file in advance, it takes me a few minutes, but I have a clear idea about what the problems are, okay? And that's the tool, the first tool that I wanted to show you. So this tool gives me information about, let me see, information about what is in the model without having any data about the model. I don't have the customer, I don't have the sales, I don't have any transaction on the model. So this file that I've shown you, so what is this VPAX format? There is an open source library that manages this file. Nowadays, we have this library integrated in Bravo for Power BI, DAX Studio, Tabular Editor, and I think there are also other tools that already adopted this library. And I didn't update the slide, but we also released a version of Vertipack Analyzer that works on a command line on Windows, Linux, and macOS. We have, I think that this is the first Pro that someone released that works natively on macOS and can do something with DAX, right? Because actually it shows data, and actually it connects. So the command line can be included, let's say, in a batch where every day you extract the information from your model. You say, Marco, why should you do that? Well, to analyze how the model grows over time. If I create a VPAX file every day of my model and I get this data for, I don't know, 6 months, guess what? With a small amount of data, I can see trends. I can see where we are going in 3 years, because I can project, oh, this table is growing with this speed, but this table is not growing. If you want to do that without this tool, well, you have to reinvent the wheel. You have to create queries, create your own format, and so on. So this is just the first step, the command line tool. And another thing that we implemented recently, let me check if I had the latest version of the studio. Yes, is the following. When you connect DAX Studio, so now I'm skipping to DAX Studio, but just to show the same feature. When you connect DAX Studio to a model and you use the view matrix, now we have a few additional properties that have been defined to optimize the consumption of Direct Lake. Because by default, what previous versions of Vertipack Analyzer did we basically scan the entire model, all the columns, which means that in Direct Lake, you bring everything in memory, which could be, wait a minute, no, we don't want to do that. So the default option we have now is resident only, which means that the VPAX file is only populated with the statistics about the columns that are in memory. If you need everything, you have to be explicit, because this could be very expensive. So that is an improvement that has been released just recently, and this is the latest version of DAX Studio already has this property that is has been implemented into the library a few weeks ago. And this is just a feedback we received from people who were using Direct Lake. So basically, the information from Direct Lake is the same. Why? Because more or less the organization of the data is the same, and so the statistics we obtain are the same. There is something we could tune for Direct Lake in the future, but actually, I think they are details. We can actually do most of the job with what we have today. So VertiPack Analyzer is the Excel file that can consume the VPAX file, but the library is what you need to do your own integration. If you want to do something with this format, you already have a library that does pretty much everything. So you don't have to reinvent the wheel. Any questions so far? Cool. Okay, so back to our problem. Okay, now we know what we have in the model. We know that we can extract statistical information, but how do we solve a performance issue? So the tools that we need to do that are basically two. One is Performance Analyzer, which is part of Power BI Desktop, but this is in the cloud. Sorry. And in the sense that we don't have a Performance Analyzer on the cloud, on Power BI service, okay? Performance Analyzer works on Power BI Desktop at the moment. And then we have DAX Studio that can work locally, but also connected to Power BI service. So DAX Studio doesn't have an issue from this point of view. How do we use these tools to isolate the problem? Remember, my issue is the following, and now I go back here. This is the model. This is the report that I have for the model that you have seen before. Let's take a look at this model. This model is small. Okay, this is a small model. From any point of view, this model has only 62 megabytes of data in memory. This model has the largest table, 2 million rows. I don't qualify this as anything else than a small model. This is a small model. From any metric, any point of view, this is a small model. Which means that in a small model, everything should be that fast, right? I do click, down. There is no others. Now, let's try. Let's see. What happens if I open this page, right? So what can I do here? Let's drill down 2010. Please zoom it. Here we go. This is a slow report. By any metric, this is a slow report on a small model. Okay, that is from any point of view. We intentionally made something that. So now we finally have the value, but we can do something, right? So in this report, we have two measures because we have sales currency and year-over-year sales currency. Something is going bad, and we want to understand what. So what we do is we use this performance analyzer pane, which allow us to track events in the report and record information about what is happening. In order to do that, first of all, we have to start the recording. From now on, every action I apply to the report will generate events in this page. For example, let's click 2011. Wait. But you see that if I had multiple visuals, I will see for every visual the events generated by the visual. I could show this in another file, but what happens is that you will see multiple visuals. Each one has a sequence of events because each visual has to, one, prepare a DAX query, send the DAX query to the engine, it could be the local engine, it could be the remote engine, retrieve the data, populate the visual. Now, the part, prepare the query, send the query, execute the query, wait for the data, is this the first line, DAX query. Then visual display means collect the information and show the data in the report. If you have a map with 20,000 data points, you might see that visual display is slower than DAX query. But if DAX query is slower than visual display, well, the DAX query is a problem. The number is in milliseconds, which means that we waited for 18 seconds to get some data. Other, in this case, is just a small number, but when you have many visuals, other could be a bigger number. Guess what? If you have 20 visuals in a page, the computer doesn't run 20 visuals at the same time. It could run 2, 3, maybe 4. So basically, there is a queue of visual. So visual 1, do something. Visual 2, do something. Visual 3, wait. That waiting time is other. When you see a big number in other, take a look at the other visual, because basically what is happening is that a visual is waiting for another visual. That's the reason why when we want to spot the bottleneck, we try to isolate, we try to ignore other. And so if you look at the duration, it makes sense to sort the duration by DAX query, for example, right? Because if we sort by DAX query, not by total time, we will have the slowest visual from the DAX standpoint at the beginning, even though technically is not the last one or the slowest one to be displayed, because the last one that you see could be a fast one that just has to wait a lot. So that's the first thing. So look at the DAX query time when you have multiple visuals. What do we do at this point? We can copy the query. Now, we can run this query in the DAX query view, but I don't want to wait another 18 seconds to see numbers that I cannot use, because the DAX query view nowadays doesn't help you finding a performance issue. DAX query view can run a DAX query, but doesn't have the instrumentation to provide me information about what is going on. So at this point, remember, I copied the query in the clipboard. So I can go, I can show you, if I go in DAX query, I can paste the code here. I just don't want to execute it. But basically, this is the code that populates my visual. Okay, this is the DAX code for a query. I can paste this query in DAX Studio. Let's go here. I already have DAX Studio here. And I paste the code here. Now, before executing this query, DAX Studio has these tools that enable me to investigate in what is going on. And the more important tools that I want to use now are these two, query plan and server timing. So when you click on these two buttons, what happens is that DAX Studio does something similar to Performance Analyzer. It connects to the engine and says, give me information, give me events about what is going on. And at this point, if I look at the query plan and the server timings, now they are empty because it is waiting that I run this code. Before doing that, it's a good idea to set this button clear on run. When we want to analyze the performances, we want to clear the cache every time. We want to run the query in the worst possible execution environment. We want to optimize for the worst case scenario, not the best case scenario. Optimizing for the best case scenario, we have data in cache. That's easy. We want to know how to get the best performances also when we have no data in any cache. So we click on this button and then we click run. Now I have to wait 18 seconds and I'm open to your questions if you have one.
Power BI, when you're doing performance analyzer, you're waiting 18 seconds for DAX query to pop up, even at the bottom. Which probably not your question, but why do they know what the DAX query is already? Why can't they show it to you straight away?
But you can copy the okay. No, I got it. That's a good write to ideas.fabric.com and please, yeah, we will. No, it's a good idea. It's a good idea. Having a mode where generate the DAX code without executing it is a great suggestion, in my opinion. Where's Darren? Darren, where is Darren? It's a good idea. Okay. Eh? Yes, but before it completes, yeah, before it completes. I didn't know that. Oh, that's nice. Okay, there is a trick. I thought it was at the end. Ah, good to know. So if you use this other button that I will use later, maybe, if you click on all queries, then you start the query, you should see the query before it finishes. At that point, you can cancel it. And good suggestion. I didn't know that. Good. Wow. I learned something. Okay, good. Now that we clear the cache, we discovered that the problem is worse than what we expected, because by clearing the cache, this query ran in 48 seconds. 22 seconds have been spent in the former engine, 25 seconds in the storage engine. What does it mean? So let me check if I have the slide here, because I don't remember. I don't remember it, the slide deck here. Yes, okay. So what does it mean? Basically, this information is more specific about what is going on. Technically, if I analyze the query plan, I have more information about the logical and the physical query plan. And a good information here is, you see that the query plan has thousands of rows. It's impossible to understand what is going on in the query plan. But one information that is easy to catch is to collect this metric, which is how many records have been consumed by specific points of the query plan. So what I'm discovering is that there are many points in the query plan where a storage engine query, guess what, these queries, is returning rows to the formula engine, and the formula engine is doing some operation that is very expensive. You can see from this timeline that actually what is happening is a complex interaction between formula engine, yellow, storage engine, blue, formula engine, storage engine. So it's a continuous back and forth between the two engines. And at this point, you say, okay, Marco, but I want to understand what is going on here, what is happening, and blah, blah, blah. You have two options. Option one, 800 pages of book. Option two, 40 hours of video. You have it. Yeah, I mean, because we have the information here, but understanding the meaning, it's like, you have a 747 autopilot, it works. Then something goes wrong and you see a lot of alerts and you have to do something. Guess what? You hope that you spend many hours on this in the simulator, right? And this is the same thing. So if you want to understand all the information that we have here, of course, this needs time. And my goal today is to show you the tools, the techniques that we use. So the idea is that if we reach this point, we can start looking at the code of the measures that we used. So we have two measures here. I think this is visible here. These are the two measures that we have in the visual: sales currency and year-over-year percentage sales currency. When we investigate the performance issue, one thing that we usually do, first of all, I could comment these two measures to isolate the slowest one, because probably one is lower than the other. I want to focus on the slowest one, but I know that this measure year-over-year, internally, it evaluates sales currency. So what I can do, let me comment this one, and let me just start to, so let me investigate, is sales currency the problem? And I can run the query, and hopefully it will take a little bit less, because not having the year-over-year, there should be some lower amount of time spent. And my next step will be to include the definition of sales currency into the query. Because when I do that, I will be able to see the DAX code in the same window of DAX Studio. And without touching my model in Power BI, I will be able to manipulate the query to find a better implementation of the query. So for example, I can go here, sales. So what is the measure here now? Sales currency. I select the sales currency measure in here, and I right click saying define dependent measure, because sales currency has an implementation, but internally it will compute other measures. And when I do an optimization analysis, I want to have all the measures in a single place. So we see sales currency is a measure that internally uses sales amount, internally uses conversion rate. And if you look at the following part of the code, we had the definition of sales amount, the definition of conversion rate, and so on. Use format query to make it nicer. But the idea is that at this point, having everything here defined in this single file, if I spot a possible optimization, I can change the code. I'm not changing the code in my model. I'm just simulating what would happen if I change the code this way, this other way, and so on. And if I remember well, the problem is caused by this code. Okay. Now I show you. I wrote this code, so I know what to do. But if I spend some time on this, I could say, okay, oops, sorry. Instead of writing the code this, no, come on. Okay, instead of writing the code this way, the problem we have here is that this sum x is iterating a few million rows, 2 million rows, but for each row is invoking an if statement, which is already a bad idea, and then is invoking row amount, which is another very bad idea. So I know that a better definition of this measure is this one. I could compute raw amount where the sales quantity is greater than 0. That's what I want to do, okay? And if I do that, remember, now we ran this code in this amount of time. So I analyze the query plan, I analyze the server timings, I have an idea. Oh, found it. I run this code now, and it should be slightly faster. Not enough, but we had 17 seconds, too much, and we have now 9 seconds. So it's not enough. So there is something else I have to fix. So I can take a look at the code here, and probably I will realize that, oh, my sales table has 2 million rows, and for 2 million times, I'm computing the sales amount multiplied by the conversion rate for that specific currency code here, and the specific date probably, right? Because there is a date in conversion rate that is evaluated. So at this point, let me check here, conversion rate, currency, last currency date, and so on. So yes, it's, but because I know that looking at the code of conversion rate, the conversion rate depends on the date and on the currency. Now think about this, you have 2 million rows. Does it make sense to do the conversion rate for every row? Or is it better, I mean, 2 million times we have to look at the conversion rate. Come on, if I group the rows that have the same currency and the same day, I will be able to do the conversion rate once for that group of rows. So instead of iterating sales, I could iterate just the currency code, which is here. And let me check what we have here. Last currency date. Last currency date is currency exchange date. But I would use a date is safer. So I use here this one and date because I know them all. So that's another long thing to do, but okay. So if I write the code this way, now I'm reducing the iteration, and because this is an additive measure, the result should be the same. I'm shortening the cycle of the optimization, but just want to show you that by applying this other optimization, now I went down to 500 milliseconds. Remember, the initial point was 17 seconds for this measure, and now with 2 fixes, I went from 17 to 9 seconds, from 9 seconds to 500 milliseconds. I know DAX, I know the model, and so it doesn't take a so short amount of time to find this. But remember what I fixed. I fixed 2 things. I fixed this problem. So I changed the implementation of sales amount, and I changed the implementation of this calculation. Okay, these are the 2 problems that I fixed. At this point, I could copy and paste the code for these DAX measures and my model will run much faster. We can do that just to make sure. So if I copy this code, sales currency, I go back here and I go in sales currency and I paste this code. Oh, let's go back here. Paste the code here. Sales currency is here. So I had the code in the clipboard. I paste the code, and now you see that I use summarize. And the other thing is the sales amount, which should be implemented by using this calculate, which is here. And now, if we go back to now, remember, I only tested sales amount. I didn't test the year over year, but I guessed it is. So now I navigate. Now it should be good. Okay, you see that every time I click, it's good enough. To be honest, there is still something to optimize, but I could say, well, it's good enough, and let's go. If I go to Performance Analyzer, just to make sure, I go to Performance Analyzer, I start the recording, refresh the visual. This button, the refresh visual, forces a refresh of the visual, and you see that my query is down to 338 milliseconds, which, from my point of view, is good enough. We probably can cut some other milliseconds, but that's good. Okay, I will not move. I will not go deeper than that for this model. So we have seen one, Performance Analyzer isolate the query, isolate the visual, the query, but then in DAX Studio we isolate the measure, and then we start an iteration over query plan, server timings, measure definition in order to solve this. There is someone that is should you okay, no, they muted it because I hear the audio from the conference call. Now all the tools that I've shown you so far are open source, free, not open source, I mean Performance Analyzer, no, but they are free. Basically, you don't have to pay for them. But we spent a few years writing a tool that is a commercial tool that tries to do what I did relatively fast, but with a certain experience, without requiring any skill. Starting from the same VPAX file that I've shown you. Okay, the VPAX file doesn't have anything other than the DAX code, the tables, the columns, the statistics. That's it. DAX Optimizer is a tool that you can try by going on this website. So daxoptimizer.com. You can see how it works. There is a walkthrough. You can create an account. You can try the model tests that are available, and you can see the UI. I show you now how it works. So if I go to the app that I opened here somewhere, because I just did the login, I don't want to spend time on that. Here, the model that I've shown you is the model that we use in the sample walkthrough. What does it mean? If I upload, so let me show you how it works. So if I go, for example, to my workspace, and I could say, well, let's create this one. I could create a model, and here you have the instruction, and you can just upload the VPAX file, choosing a license, of course, but then you can upload the VPAX file. You just move the VPAX file. The VPAX file is moved to the cloud, okay? If you are concerned about, Marco, we have sensitive data, the name of the measure is already something sensitive. Okay, you can obfuscate the VPAX file. There is a tool to create an obfuscated version. So you have a local file, which is the real names, and these names are replaced with A, B, C, and so if you lose that file, it's your problem, because that file is necessary to decode the result of the cloud service. And once this file is sent to the cloud, within 5 minutes, you get this diagnosis of the problem. Let me go to the sample walkthrough because this is more accurate. Okay, so this model has been analyzed. Remember, we don't have the data, and we don't know how much time it takes to execute the model. But because of the statistics and because of the measures, by the way, the model has 151 measures, and we have no idea about which measure you are using in the report. We don't know the report, but we are able to analyze all the measures and find all the issues that exist in the model. And the analysis tells me, oh, look, these are the 20 issues that I found, and the priority of the issues is this one. So if you have time, please spend time on these first 2 issues, because these have the biggest impact over the model. And as you see, the first issue is this one. This code that is highlighted now says the SUMX function contains an if predicate on a single column fitted in the iterated table. What does it mean? If I look at the knowledge, if I open this and I read the description, I can see an explanation of the problem, and I can see examples of how to fix the problem in my code. Not in my code. The example here is not adapted to your code, but you see examples that should be very similar, and these examples provide you possible suggestion about how to fix the code. In particular, what I did, I think, is very close to this one. So we had a SUMX if condition measure. We wrote calculate sales amount, keep it. I forgot keep it, but in this case it was good, the same. And this is exactly the example that I have. So this is the first one. Let's take a look at the second one, which is this one. Oh, it's still the same. Context initial iterator. Let's say that we fix these 2 problems and we move forward. So let's fix this one. Sorry, I have to go to the other example because this is a demo. I cannot fix it, but I can go. I can show you with the other model here. Kernel, Contoso. I have another copy of the model. Come on, not here. Test. Contoso 1M. I don't think it's this one. No, it's my workspace. My workspace. Okay. So here, I show you the user interface for that. So if I another one. This is the right one. Okay. So in this case, I can say, okay, I don't fix. So this is a website, okay? I see the information and I fix the code in my model. I apply the correction and I say, okay, this is fixed. Okay, fixed. Okay. Because this is shared, I don't have that. Okay, sorry. I cannot show this one in this example. I used the wrong example, but if you click on this fixed, this issue will be removed from the list and you will go to the next one. So the prioritization that we see, let me go back to this. The prioritization that we see here changes dynamically while we fix these issues. We declare them as fixed, okay? And if I move forward, you see that the next issue is this one, which is exactly the problem that I solved with the next example. So the idea is that it's an iterative process, but at this point, with just a few minutes and no particular knowledge, this tool helped me find the bottleneck and suggest me what to do. That's the point. And the tool didn't know that those 3 measures are the slowest measure of the report. We didn't inform about that. Marco, you created this, you cheated. You created this problem and you created the demo, I know. And you're right, by the way. However, we presented DAX Optimizer in March. We went to Las Vegas, where there was the Fabric conference. And we asked people, oh, guys, if you want to try DAX Optimizer, come to the booth, and we optimize the model for you. And we asked the authorization to show the results, and we obtained that. So this is a model that we received from a real customer. Just to give you a context, this model is a model of data about real estate. Okay, it means that we have buildings. People rent a flat for some time. They have a lot of measures. Look at that. They have 678 measures in 112 tables for 4 gigabytes of data. This is a medium model. Make sense? Medium model. It's not very large. Is because the tables are large, but they are not. the tables have many columns, but they don't have so many rows. Okay, they have a few million rows, but not too big, not too big. But it takes memory. And we just processed the model, and we found this. We found these issues. Remember, we have hundreds of measures, and I don't have the record, but this guy was here. I mean, we said, okay, you have the problem in this measure. Number of units within 30 days. This measure is 2 orders of magnitude slower than the second slowest measure. Okay, that's the important point. And let's take a look at the problem. Because in this case, I had to be honest, the tool didn't suggest the solution. But the fact that we were able to find the bottleneck in 1 minute helped us to understand what was going on. So if we take a look at so this measure has different problems, but if we take a look at the problem here, so no, I have to go not here, but here in measures, this one. This is the list of the measure. This is the list of the issues in the measure. The biggest issue, so 96% of this measure is impacted by a single issue that I'm highlighting now, which is this. Now, let's try to understand what is going on. My point is that it's a question of efficiency. I have a limited amount of time to dedicate to the work and to the life in general, and I want to dedicate where it matters. The fact that I can spend more time not looking at a list of 100 measures, but being pointed here, this is the lowest measure, and this is the point that is lower. I can say, okay, what is happening here? Let me try to understand. There is an add columns here that aggregate by unique key and building key. If I want, I open with DAX Studio the same VPAX file, and I can tell you that there are around, if I remember, a few thousand buildings and 10, 20,000 units. Information I have in Vertipack Analyzer. For each unit, because this summarized add column, so for each row here, we have a context transition. So for that unit, iterate the resident table. Now, if I look at the diagram, I can tell you, because imagine the diagram. So you have the units, you have the resident, and then there is a table that has the connection between the two. But the table that has the connection is the move-ins, which means that it's like you have customer and product. What happens if you have 10,000 customers and you iterate 10,000 products? You iterate 100 million of combinations, right? Which is exactly what is happening here. We are iterating all the residents, not just the residents that went in that building at least once in their lifetime. By understanding that, we say, oh, wait a minute, we made a mistake. We should have used here, I don't know, summarize unit status to some. We could have built something to reduce the number of combinations that we have to iterate. And believe me, the suggestion that DAX Optimizer provides is not that helpful. I know that, because we don't know, we have no idea. We say, look, this is expensive, because the engine knows that if you iterate this table and you multiply this iteration by the number of combinations here, it's a lot. And by analyzing all the other measures of the model, this is the slowest one. If it happens that you have this measure in a report, that is certainly slow. And in my experience, when we look at the model, if you have a slow report, the slowest measure is usually in the top 10 slowest measure of the report, or of the model. Because yes, if a measure is not used, we detect the measure the same. So we have space for improvement. But the idea is that we don't have, because we don't have access to the data, we don't have access to the tenant, we don't actually optimize our report. We optimize the model. And even though we don't provide the right suggestion, just the fact that you have this tool, it saves a lot of time from my point of view. In other words, nowadays, if sometimes I help customers with the performance issues, and I don't even start a call without having run. I mean, I run this tool first, and I get it's like you get all the exams, and you say, okay, this is something. If it is easy, okay, I don't even start the call. Oh, look, fix this. But if it is interesting, Then I start the call. And now think about when you go to the doctor. Do you want to have a case that is boring or an interesting case? I always want to be the most boring case in the world from a doctor. I don't want to be the interesting one. But so that's the idea. So because interesting. So this is new. So no. So DAX Optimizer is a tool that performs a static analysis of the code. It identifies the bottlenecks. It identifies possible, let's say, anti-patterns in DAX code that can be improved, and it just prioritizes your effort. You still have to know DAX. You still have to know what you're doing, but it makes you more productive. And so that is more or less the list of the action. We extract the VPAX file, we analyze that, and then we review the issues. Of course, you can always use the other approach, but my point is that it is just more expensive, because even just the time to isolate the problem, it takes more time than just running the analysis and see what the diagnostic tells me. That's the idea. Just to end this promotion, we use now DAX Optimizer as an emergency tool, right? Oh, something is slow, what can we do? But in reality, we suggest to use this as a preventive tool. So instead of having a problem, try to analyze the model before even deploying it, because it makes sense, and it is easier to keep the model always clean without issues and probably in good health. However, beside the tool that, of course, I worked with Daniel Oettinger, who is the author of Tabular Editor, and also with other people that helped us with the infrastructure, the cloud infrastructure, and the user interface. We implemented this tool that basically moved into an algorithm the knowledge we have about the models. By the way, the tool that you have seen is based on Azure. And we also have a region in Australia. So you can decide where to store the VPAX file, even though they're obfuscated, and you say, okay, I want to keep them in Australia. So Australia is one of the regions that we already enabled. But the approach is always the same. First, optimize the model. Second, optimize the DAX code. Keep your model in shape. So that's the message. Questions? Yeah, come on. I know that. So I would like it just not something that you can expect in the next few months. It's a very long-term project. I have ideas about how to do that. We started to investigate a few things, but it will take a while. Because the problem of the optimizer, the model optimization is, so, okay, let's split the problem in two, right? Finding clear issues in the model, that's probably something we will do with the current infrastructure. I mean, potentially there are things that we can already find without having a more sophisticated way to analyze the model. But the problem comes when, how can I suggest you to change the model? In order to suggest you something, I should understand whether the model is actually something that you need or is a, let's say, wrong implementation for another requirement. And that is not possible without an interaction. Now, how can we make how can we create an interaction between the user and the analyzer in a way that we can collect additional information? I mean, it's technically possible, but it's not easy. If you look at the tool where you help people creating the proper model, that's probably easier to do. So not as a diagnostic tool, but that takes long, because that means that developing a number of things that today we don't have. It's a long journey. Yep. Yes. I know. So I ask you, what would be enough for you to evaluate, because that is a sort of question. If you think about the problem, the highest value you get from DAX Optimizer is the first analysis. The moment you give that analysis for free, you gave up 90% of the value of the product. And one analysis of one model without any limitation about the number of tables and the number of measures is $45 US dollar. Sorry. I mean, we try to keep it as cheap as possible. If you that is the highest cost, because if you create a subscription, the cost goes down to cents per analysis. So it's actually not that expensive. But the problem is that if we have a free, so what is the free model? Because, for example, we thought about, okay, let's I run the analysis of your model and I tell you, oh, there are 200 issues. Are you happy? You want to see the issues? Okay, so which issues should I show you? The bigger ones or the smallest ones? But the small model doesn't have many issues usually. But we have, so if you want to understand how the system works, we have a walkthrough with sample file. You can download the sample file. You don't actually execute the analysis, but you can see step by step the entire process. So it's already there. Yeah, yes. That is already online. You create an account. If you create an account without doing any, you create an account, you log in, and you have the sample files in your workspace. You have the documentation. You have videos. You have a lot of things. That's already there. But if you give me your model, the question is, okay, what will make you happy? That's a real question, because we thought about the problem, and we thought that it could backfire. Because if I tell you that the model has many issues and I don't show you them, you might think that is not fair, right? You might think that is a way to. So we prefer to say, no, look, this has a cost. Okay, you want, even because if you go. You do you go to do a blood work, you pay, right? It's not that you pay if you are not healthy. You pay anyway, right? The exam has a cost. That's the same principle. One second.
You said that import is about query. Import is about 10 to 100 times faster than direct query, right?
Yep.
I kind of agree with you, but we had a customer transaction file of 5 billion rows, and we could not import it.
Okay.
Okay, in WordPad.
In Power BI, 5 billion rows, we can work with 5 billion rows.
Whatever, it's a long time. So isn't direct query applicable there? Or wouldn't you use direct query? Because you're not bringing the data in.
So from my point, okay, 100 billion rows is the area. It's an area where I will not import the data. Okay, 100. 5 billion rows is something we can manage. I seen several. I understand, but the thing, okay, we have to understand which part of that data is actually needed in memory, because it's possible that you might load most of the columns for the analytics in import mode, and you keep in direct query mode another fact table that has only the details of the transaction that you don't really need. For example, you have a notes field with a string different for every transaction. Come on, we don't want to import in memory that one. But you also never query that column. That's the point. That could be a solution for this is one of those cases where DirectX is not bad. However, DirectX and import mode are the same from the point of view that they load in memory only the columns that are used. This is not a specific feature of DirectX. In import mode, if I have 20 columns and I use 2 columns, only the 2 columns that I use are loaded in memory. Okay. And this is a feature that has been online for more than 4 or 5 years. And now, oh, direct, we only consume, we only load in memory the columns that we use. Yes, but also the import mode does the same. I mean, the key for creating a large model like that is to manage partitions. So you have to spend, so it's not some, you cannot expect to use Power BI Desktop without Tabular Editor and work with that file. No way. You need to use a serious tool. Tabular Editor 2, Tabular Editor 3, Visual Studio. These are the 3 tools that you have to use. Power BI Desktop does not fit the bill. Here. Question?
Just wanted to share the use DAX optimizer in
Thank
the
you.
project, which was really in April. So we just released it.
Yep.
And we've done work for 4 or 5 months, massive model. And it actually was so slow that that's it. The customer was saying, that's it, we can't use it, right?
Okay.
So DAX optimizer, I said, okay, I need to try. I looked at it. I have 400 measures in the model. And I bought one run. Like, I'll buy one run, like $50. It's not much. And it showed me 2 measures and actually it suggested the improvement. So it was the good suggestion. I done it, and I'm not DAX expert. I'm kind of. So it actually worked really well. I've done 2 measures, and it improved 10 to 20% performance of the whole model, and it took me 1 or 2 hours, right? If you calculate the cost, I would spend a week or 2 just going through this whole list and go in this DAX Studio. So if you compare, daily cost of the consultant, you will see that DAX optimizer is just cost you nothing, because you will spend 10, 20K just doing that manually kind of work.
Yep.
So from our perspective, it was like brilliant. So just want to say that it's a great tool. And I think if you have that problem, then just use it and see whether it works. And it's a good chance that you hit the right thing. And if it doesn't, you go other way. So.
First of all, thank you very much. I didn't pay him. And I just want to add one thing. The use that I do today is mainly as a tool to see the cost of the metrics of the measure. That is, we made an improvement. We released 2 weeks ago an improvement to improve the visualization of the metrics in the issues, because we understood that we could have improved the prioritization of the individual issues. Before the version that you tried, they were prioritized by measure. Now, if a measure has many issues, we also prioritize in the first list. We prioritize the individual issues, because you go more straight to the issue without spending additional time. Question.
Great tool. So for utilizing this tool, what is the best time to use it? Development time?
That's a good question, because as soon as you have some data to test the model, not let's say not 2 rows, okay? So you need a relatively good amount of data. As a sample data is good, but a relatively good amount of data in your model. At that point, you could start, because if you have an issue, the issue is already there. It's not that if we find issues in the code, we show the issue in any case. The statistics are for the prioritization. So when you have 200 measures, you don't have time to fix 200 measures. No way. Especially if you are at the end of the project. But if you are at the beginning of the project and you have 20 measures and you run the analysis every day, that's a completely different perspective. I didn't mention Tabular Editor 3 has an integration today with Tabular Editor, so with DAX Optimizer, so that within the environment of Tabular Editor, you can see the list of the suggestions, click on the suggestion, go in the code, and within the same window, you have a complete integration. So it becomes like a system to help you improve in the DAX code. And there are a number of features we want to add in the integration with Tabular Editor, just to further improve the user experience. Because, for example, today, you have to run a new analysis. But imagine this, you have an issue, you change the code. Did you fix the issue? You need another run. So one thing we want to do, we want to reduce the time required to run another run just for a measure that you modified. We would like to be able to say, well, you made this change is good or not. Because we can suggest something in general, but you are responsible to write the right code. You know if that code is good or not. We can only make, oh, this could be the problem, but you have to validate it. Once you do that, we can run the analysis again. And today you have to run the analysis of the entire model. So the suggested workflow today is that you run an analysis, you apply a batch of correction, you run the analysis again. So you don't do the analysis every 5 minutes. You do the analysis once every 1, 2, 3 hours, something like that. This is, I think, because that doesn't, otherwise doesn't make sense. But in reality, we could shorten this time. We could say, okay, not the entire analysis, but the analysis of the changes that you made, that could be faster. So that's an improvement we have in the pipeline.
Get the results back. Those two measures were real. If you sort them out with the other, which are probably bad, not as good as those two.
No, but this already works, because if you run a single analysis, when you check, okay, done, then all the other issues move up. And the scale that you have seen is dynamic. So what you see now, this is the 3, and the other is 3000. Well, once you remove 3000, the one that is 3 now is 3000. So it's always a question of how much time you have. And my suggestion is that if you fix the 20 measures, let's run it again, because if you know that if the order of magnitude was similar, then you want to fix all of them. But if you see that the order of magnitude is very different, maybe that it is enough. Maybe that you still have issues that could affect the model later when you have more data, for example. And so when you have a small model, then my suggestion is that during development, if you start from the beginning, just run the analysis as soon as possible, because this maybe once a day, so that this way you don't keep something untouched. There is only one problem. Sometimes we have issues that are not, let's say, that we don't know if it is an issue or not. Which means that if you have an iterator with a context transition, that is potentially an issue. You might declare this is something you have to ignore, because it is what it is. But you might underestimate the impact of that. You might say this is not a problem, but this could be a problem tomorrow. We found the issue, we told you, and you said, that's okay, I want to ignore it. That is a situation that is borderline, because we are not able to, you said that this is to ignore, because what happens is that if you declare to ignore that, in the next iteration, we will continue to ignore that unless you change the measure. If we see that from one version to another, you didn't change the measure, and you said, no, this is good, okay, we don't do anything. And at that point, but if you change the measure, well, you change the measure. You say that this is okay, but now you change the measure, so validate again. So that's already in the flow. Question? Okay, let's marketing. So we try to. So the idea is that, let's see the monthly cost. Consumption is a single run, no limitation. Every run on a different model, you do what you want, and you can have discounts by buying more runs. Okay, you can use at any time, no problem. Or you create a subscription, which means that you have a number of models that you can use within a month. So for example, if I have this subscription, I have 5 models with the statistics that come from Power BI desktop. So if you have your model with 2 billion rows in the cloud, you cannot get the statistic from that. You have to go there. But if you do this, you have, okay, I have 5 PBX files I'm managing, and overall, you can run 20 analyses per day, which means 2 by hour. You can share this license across your team. Okay, the license is not by user. The license is for the company. Then there are ways to share the license and so on. But the idea is that this is the cost for the analysis. What happens if I have 6 models? 2 options. You extend the subscription, you increase the model, or you wait. If I assign the model today, the model is assigned. You have 5 slots. You assign the model for 1 month. You cannot remove it, but after 1 month, you can replace with another model. So I think that for many consultants, this is very, very good, because if you have 2, 3 customers, the cost per analysis is minimal. Then, okay, the difference, the service is the only difference with the service is that you can get the model from analysis services on premises, Azure analysis services, Power BI service. The VPAX file can come from there. The enterprise has the automation and has the unlimited runs. So this is because if you have a pipeline for deployment, then you could say, okay, the analysis of the model is part of the deployment. If I find issues, I don't deploy to production. And I go back with a message that says, fix it. And that requires unlimited run because you don't know how many. So that's, but again, that is, again, per company, because you can say, you can assign the license to a single user, or you can say, oh, I create a group, I assign the license to this group, and this group manages everything. That's fine. So that's if you want to create 2 different groups with different group of users, you need 2 licenses. Okay, if you assign the license to a group, everyone share the same license. That's the principle. That's the cost by month. If you get by year, you pay 2. Yeah, go. Okay.
Mine's a comment. I just wanted to thank you for your calculations prior to the presentation. Just because just being able to teach people DAX, really good introduction to them, and I can help them solve their problems quickly without having to introduce complexities of
Yeah, thank you.
So
Thank you. Right, but actually, it's Microsoft that implemented the feature. We try to push a little bit. Yeah. Question? I have a strong opinion about that. I don't want to be too negative. My suggestion is the following. The day you see any tool, any LLM producing good SQL code for any database and any model, at that point, you can think to start to look at what will happen on DAX. But until you don't see that day, you have no hope to see this happening for DAX. And it's easy. The amount of examples and data for SQL is orders and orders of magnitude bigger than what you have for DAX. And nowadays, there are no models that can create SQL code good for any data model. Everything I have seen so far works with a number of constraints that cannot be applied on any production model. Challenge me if I'm wrong. I know this space, so we can discuss for hours.
Could ask Marco questions for hours. I don't want to take up all his night. Thank you, Marco.
Thank you. Thank you very much.
Amazing. Yeah, obviously, I know there's people in this room that are going to buy this tool. Yeah, amazing, and as always, great. So it's good to see you.
Thank you very much. Thank you very much. Thank you.
Next week, we've got Lunch and Learn on Friday. I'm doing Lunch and Learn. We're going to be looking at AI skills in Fabric, and we're doing that budget model. So feel free to join me. That's online. You can get that free meetup. So come and check out Lunch and Learn. That's fun. That's mostly me getting things wrong, so it's always fun to watch. We're also got 2 meetups next week that are worth going to because Rad is in town, as I've told many of you. We've got Kelly's meetup, the data analyst. They're right at the back there. There's Kelly. And Martin are doing the analytics. What's the name of the meetup? I always forget. Data platform. The data platform meetup is happening at the Microsoft office, which is where we had the Fabric roadshow. If you guys are doing that, something on Tuesday. So if you can't come to the Reza one on Wednesday, then go to the data platform meetup. That'll be on meetup as well. And you can go and see Reza on Tuesday. Reza and Martin, and there's a good bit of another community speaker, all doing stuff on some Fabric and data platform stuff. So if you're keen to check out Reza stuff and you can't make it Wednesday, then feel free to go to that one on Tuesday. Check out Kelly's meetup. Otherwise, we'll see you here next week for another exciting episode, Super August. We've got Marco then Reza. I'm super happy. So welcome.